Hi, welcome to the first lesson on the hazard unit, which is an optional unit of the A-level AQA course. Although it's an optional unit, it's one of the most popular units in the physical paper. This goes with paper one, physical geography. I would say about 95% of the schools follow this unit. So you'll do everything from things like earthquakes, volcanoes, tropical storms, fires, wildfires, and cover some other subsidiary things. So lots of case studies with it. Big unit, really important unit, but great fun as well. So the first lesson is we'll follow the specification. So I'll just switch on to that. So all the lessons will follow it in the order which are in the spec. That will make it easier for you to follow your checklists that you have, and if you're using the syllabus, you can cover it. And you can see the first section here. It's packed with lots of keywords. Very important to learn your keywords because they show up in the 4 markers. They embed within your own answers when you're showing off your expertise, and they're often incorporated within the question. If you don't understand what, like, the hazard management cycle, and it plays a fundamental part of the question, you're going to struggle to answer it very well. Okay, so lesson one, which is what this is, will cover the first two sentences within this. So I'm going to look at what we mean by hazards, distinguish it from disasters. Going to the broad categories, you can see in brackets geophysical, atmospheric, hydrological, and then a section on what we mean by hazard perception. Now, where it says economic, cultural determinants, they're factors that influence how you see a hazard. Now, hazard affects our behaviour, affects where we live, the activities that we do as well. Beyond that, where it goes characteristics of responses, you see words like fatalism, prediction, etc. I'll do that in lesson two, and I'll go into two theories that you can see right at the end there. The hazard management cycle, the parts model, they feature quite heavily right across everything from 4, 9, and 20 mark responses, everything from the shorter responses to the big essay-like ones. Theoretically, they can be found even in the 6 markers. Okay, so let's get started on doing some specific content for this first lesson. So just to make it clear what I'm doing in today's lesson, you can see that first aim. There are 4 sort of things I'm going to try to achieve today: definitions, classification, explain hazard perception, and the last bit there is really quite straightforward. Just look at some of the common shared traits of all natural hazards. So, what is a hazard? Well, a hazard is something dangerous, but we've got to take it beyond that. We can't just say that, put it into context. Something that's potentially dangerous. And we usually say, like, a hazard is something that has the potential to do lots of damage, destroy buildings, damage buildings, injure people, loss of life, combination of all those things. Now, here are some of the natural hazards. Top left-hand corner is a satellite image of a tropical storm. Underneath that, that's a blizzard. Underneath that, that would be a drought. The central middle is actually, I wouldn't say CGI, it's a bit of a, that's not a tsunami-driven wave. That's someone's blended the two things there for effect, but that's what we're talking about, tsunami. Forest fire in the top right-hand corner. Underneath that, we have a flooding event. That could be anything, couldn't it? That could be like rivers are flooded. That could be coastal flooding. Could be tropical storm surge, or it could be down to tsunami. It doesn't look like a tsunami-driven bit of water there. Okay, so let's clarify that first bit. So there we go. So the definition, you're not going to get a question, I think. It's very rare to get, I think, at A-level to get you distinguishing between a hazard and a disaster, but we'll still clarify it, bring in a little bit, a tiny bit of theory into that as well. So hazard, anything that's potentially dangerous. Natural hazard, so it's nature, physical, so we're not talking about human-induced hazards. And you can see the example there of volcanic eruption, which you can see a photograph, and it has the potential. So if it's on an island and that gets earthquakes, volcanic eruptions, and they're localized and no one lives there, we're saying it's a hazard, even if it takes place. And the important ingredient that we need for it to be a disaster, we need people involved. So close proximity, right? Damage, death, destruction, that type of thing. So natural hazard, so 3 broad categories: atmospheric, hydrological, and geophysical. I'll mention that more in the next slide. But we're coming into a little bit of theory here, really straightforward theory. It's called 2 things, either the DEG model or the DREG model. And the reason why I use both those words in textbooks, it's given different things, actually stems from a mispronunciation of the geographer's name. sort of a very simplified Venn diagram. So we've got our hazard, oh, you can't see my mouse moving, sorry, on the left, you've got the earthquake event or volcanic eruption and vulnerable populations. So what do you mean by vulnerable? Vulnerable means I'm close to a risk. I'm close to where I could get hurt. Okay. So if I live on a fault line, I live by the sea, I live in a low-lying area, I'm exposed to the risk. I might be very poor. I might be in very crowded accommodation. I might be living in a shack which could easily topple over. That's vulnerability. And when we push the slide into its later stages, you'll see here, look, it's the overlap, that orange bit in the middle of the two circles. That's the disaster where the two cross over. Earthquake, lots of people, less developed, poor accommodation, that type of thing. That is actually called the DEG or DREG model. You'll see that referenced again soon. So again, this is just to give you a bit of clarity to this. So different companies, insurance companies, they pay out for damage. So there's big business for them. You can get jobs in this, by the way, disaster risk management. They use algorithms, maths, and things like that. So, you know, one of interest, you could go into that field, degree level, masters, PhD, whatnot. There is like a work that you can do that follows this. And here basically saying, you know, their version would be at least 20 people killed, $16 million worth of damage, or a combination of both. Different companies will have different vibes to that, okay? Because obviously that will enact a payout, so there's a reality to it. Now, the top bit here, there's a more specific reference. Again, you can't see the mouse moving, I don't think. There's the DREG model or DEG model, and I think it's well worth learning that, because it really doesn't take any time at all to repeat and learn that. It's something you can make a reference to, and when, you know, showing knowledge impresses the examiner, certainly impresses me, and I am an examiner. Underneath in the box, it's a database. This would be used something like an IGO, which is a big government organization, intergovernmental organization, global governance. The UN would use something like that. In particular, the World Health Organization, WHO, would use this. And they've got this clarity here of any one of those 4 bullet points. It could be all of those bullet points, one of those bullet points, and then they might deem it like an international incident. That then triggers responses, financial responses, and gets people of expertise out there to help, maybe save lives. That's quite critical, isn't it? So again, I think that's quite useful there for you to learn. Then going back to that syllabus material, it says like geophysical, atmospheric, hydrological, and you can see the definitions after that. So geophysical, very much to do with the land. That, I mean, the obvious ones for that would be volcanoes going off, erupting, earthquakes being triggered. Atmospheric, that's really the key area of that is the top 10, 12 kilometers of the atmosphere where you get most of our weather, the troposphere. So things like tropical storms, droughts, flooding is interesting because it comes back, you see it in the lower one there as well. So there's definite overlap here. And then hydrological water, so that would be storm surges, floods, etc. Where it gets interesting, where again an overlap one, I would say like a tsunami, which is caused by an earthquake or volcano, causes displacement of water and would create a tsunami that goes onto the land. Now, I would say that's geophysical. It's definitely not atmospheric, but I think there's an overlap going into hydrological. And again, I don't think you're going to get a question that asks for that sort of division, but you are expected to know it. So I don't think it's going to be a big player, but you should be able to clarify it. So if it's asking you in a 9 or 20 mark response for an example of a hydrological hazard or atmospheric or geophysical, you have to choose wisely. By the time you got to that point, though, you will have been trained up so well that will not be an issue. So what we've got here is a list. And one of the activities on this slide, you pause the video and then you have a go at doing this. And as I press these things here, there's a couple of keywords I think probably need clarifying to you. But you can certainly look them up. You've got the internet so brilliant these days for doing that. So what you do is next to each of the words, once I get through to the final list here, G is for geophysical, A is for atmospheric, and H is for hydrological. And all you do is you put down the letter code next to them and what you think they might be. And then I reveal the answer when you restart the video. Right, so a couple of things. A fault rupture, which is in the top, it's the number 2 on that left-hand side. That's where the ground has moved on along an axis where there's like 2 plates, and it's caused the ground to rip, tear, break. So the rock would break. Lateral spreading means to the side, so there's movement of rock that side. That would create a hazard movement. Maybe a landslide would be triggered from that. I think the only other two words I would probably clarify to you that you might not have heard of before: liquefaction. That's where some ground is so loose, like sand, gravel, soil, has water in it, like the water table, level of saturation. Ground shakes very quickly. The water rises, the particles of the soil move apart, and it temporarily acts like quicksand, like a porridge, and that can cause issues. Going down that same column, pyroclastic, pyro is a Greek word for fire, plastic is material. That's where you get like certain volcanoes that erupt and you get all this like ash. It looks like ash. It's a hot glowing cloud, moves down the slope, burns everything in its way. So now would be your time to pause the video, and then you go G, A, or H next to each of the words, and pause. Welcome back. And here are the answers. Just quickly put those up and you can check. And I do think it's important to do these activities because it can just go in one ear and out the other ear. So having these like pauses and having a go doing these activities gets you just to pause, think, own, and embed these in your mind. Big, retrieval, embedding, very important to get these things right. Okay, and I hope this first lesson is a nice, simple, short lesson. And then, if you remember back to a few minutes ago, I said overlap. The classic would be storm surge would be both. You could argue is hydrological because it's a body of water, but its causation would be atmospheric. Tsunami, movement of water running over the land, definitely hydrological, but its causation would be geophysical. Okay. So again, it gets you to go back over them and own those words, understand them, and then that's how you impress. That's how you get stronger. So characteristics. So these are like they look quite basic, and they are shared characteristics of all hazards. Let's have a look. Let's have a look at these shared characteristics. So what we're saying is take the first bullet point, saying they have clear causes and they have impacts that you associate with them. So like ground shaking with earthquakes, pyroclastic flow with composite volcanoes, storm surge with a tropical storm, right? Second one, it's very rare that you get much warning at all, if at all. Okay, so earthquake, seconds, you don't really get warnings. You're lucky in the most advanced countries if you get 20-30 seconds pre-warning, and that's lucky. Okay, but I don't necessarily totally agree with that. And I think the short warning. What do you mean by short? So that could be several weeks because you could see that earthquake will erupt. Not earthquake. That volcano will erupt in 2 weeks' time. Iceland, 2022 December. Right, within weeks it did erupt, and they had evacuated people. So there's an element. But this again, this is in the textbook. This is in the spec. Usually, if you take the third point, we're saying you don't have much choice, especially if you're poor. I can't leave. I'm not allowed to leave. I have no choice. My family's here, type sort of thing. Wealthier nations have more of a choice. The fourth bullet point, most loss of life happens pretty quickly. And that then governs how you respond. That's why you often hear, most lives are saved within 24 hours, 48 hours, 72 hours. The last bullet point is saying, the scale, that's the size of it. Is it local? Is it regional? Is it global? The intensity is the strength of it. And that's proportional to how much often the emergency response needs to be. So a really big magnitude event often requires a big, very quick emergency response. And I think when you look at those 5 bullet points, they're not too complex and, dare I say, almost seem obvious, but nevertheless, learn them. So next section. So the 2 parts of this. First of all, what we do is I'll clarify what we mean by hazards, the impacts of hazards, and I'm going to mention primary, secondary. And if you've done GCSE, that should be quite common to you. What will be less common, you may have touched on it, but is an important player here, is the perception and what lies behind that. I definitely see that being played into some role, and students have often talked about this. okay, in parts of the response. So impacts linked with risks. Risk is, like how bad something can be, how how likely is something to happen. Okay, and if you look at these ones here, I actually going from the top one where it says death, that's very much social, and I talk about that in the next slide. The middle set there, it says to goods, that's your economic set, and then the environmental, which you talk about less probably, so probably have to work a little bit harder with that. And here we talk about this. So certainly at GCSE, many of you and at Key Stage 3 will have done primary and secondary. So primary broadly, and I'll come on to the next slide here, might as well go straight on to this next slide. And there you can see at the top, this is immediate. Building collapses, road destroyed, bridge collapses, that type sort of thing. Immediate, there's structural damage. Immediately brings on economic damage, but also I'm crushed or I drown. Immediately, I am injured. That's primary, immediate. But also there's a physicality to it as well. So an eruption, ash, lava, pyroclastic flow, they're immediate. Some impacts, physical impacts like a tsunami, would be delayed and therefore become secondary. You have to be clear about that. And definitely primary and secondary have played a role at GCSE as well, at A level, which is worse. You have to, and therefore you have to have the clear distinction. Secondary, like a mud flow, which has been caused by melting of ice, which then creates a flow of water, which mixes in with mud. That can happen hours, days after the event. But also secondary will be things I've drunk contaminated water, I've got sick, but also things like I can't go to work, my business has had to shut down, types of the thing. That runs through all of the case studies. And this will be alluded to again and again and again. So in the case studies, I always teach more than this because I'm not teaching if you pass the spec. I want to teach you to get an A star. But technically speaking, you need to know one earthquake case study, one volcanic eruption, two tropical storms, one wildfire, and then there's two other case studies that you have to do. All of them, you need to know the causes of them, but all of them you need to know the primary and secondary impacts, so the responses. So again, an important player to do. But at A level, I think you should know this an acronym, SEEP, and it stands for social impacts, economic impacts, environmental impacts, and political impacts. And through this course, you need to know those, and you could overlap these. So you could look at these relating to these. You could look. Sorry, you can't see the mouse moving. You could relate SEEP to secondary as well. And again, the more you play it, the more it becomes innate in your mind, and you can recall it. So again, you want to practice these outside of just looking at the impacts. Students are terrible usually at thinking social, what does that mean? Economic, what does that mean? You want to get good at that because it helps your planning of your essays. I put time scale in, short, long term. So short is usually like minutes, hours, days, possibly even weeks. Long term, you're going months, years, decades. Okay, so get used to using these words regularly, and then it becomes easier when you come around to the exams. So on this one here, so I've got a couple of photographs here, and we think, okay, so which one is riskier? And classically in geography, we use photos quite a lot, and you have to interpret what we call assess an objective to look at a photograph and apply the right geography. So again, here's an option for where you can just pause and you can have a crack at doing this. And what you do is you go like, just don't even have to write it down particularly neatly, and you go, okay, is it location 1 or 2? I think more at risk. Why? But there will be evidence that you've used from the photographs to make that decision. So again, here's that pause. And welcome back. If you spent 2, 3, 4 minutes, whatever that might be, as an activity. Now, in my opinion, I would say my gut feeling would be location 2 is more risky. My reasoning would be behind it. I look at that and the ground looks very loose and unconsolidated. I look to the right of that stream and I can see immediately there's a settlement that goes off into the distance. It's very close to that water source. If there's a flooding event, it doesn't look particularly wealthy. It doesn't look particularly strong. There are lots of people, dare I say it, without trying to damn them, they don't look very wealthy and they look like they might be more vulnerable. It looks like a tropical environment, and therefore maybe disease would spread quickly if there was a disaster. And I feel that that environment with the steep land behind it, it might be prone to flooding, landslides, maybe tropical storms. It's limited, but I'm speculating. Whereas when I go to location one, my immediate thoughts, it's wealthy. Therefore, I might interpret that because I can't see many buildings, but I might interpret because of that wealth, there's building codes, seismic buildings. It's a wealthy country, has the ability to respond really well. That said, if I delve into the photograph more, I can see the sign there's Hollywood. Well, clearly I'm a geography teacher, so I would know this. California, fault lines, prone to earthquakes. And I can also see in the background there's a steep slope. Doesn't look necessarily heavily vegetated, so it might be prone to landslides. But look how my mind's thinking. Okay, so I'm looking for stuff in there and I can speculate and explain what's going on. That's the sign. Thinking like a geographer, being a good geographer. And there's this word vulnerability. Very key part to, because if you take the Japanese tsunami of 2011, 20,000 people died. Most of that was because of the tsunami. Moment magnitude scale, 9. Go to Haiti 1 year earlier. Moment magnitude scale of 7. Now, total energy difference there is 1,000 times. So the Japanese earthquake was 1,000 times bigger. 20,000 deaths. Anything between 220,000 and 300,000 deaths in the Haitian earthquake. Vulnerability. More people at risk for a variety of reasons. Poor, crowded, type of ground they're living on, level of development, bad governance, all those sorts of things play a role. So that vulnerability is a huge factor, the human element. This photograph, I think, sums it up quite well. All of these are vulnerable. I think that the big picture that you see behind the scenes, that ground looks very soft, it looks very unconsolidated, it looks like it might be somewhere like Bangladesh, easily washed away by river flooding or storm surge from a hurricane or tropical cyclone, they call it around that area there. And the bottom two pictures there, squatter settlements, easily knocked down, crowded, very difficult to get responses in there, people helping, very vulnerable to physical and human factors. Whoops. Right, okay, so I just slid that a little bit too quickly, but I don't think we've lost anything too much there. So with this one here, perception of hazard. So perception is what you think, and your perception influences your behavior. I will stay here, I feel safe here, by a number of factors. So I went to San Francisco in 1990, the year after there was an earthquake, which killed, I think, around about 70 people. I felt safe. And because I felt I was in a wealthy country and my level of education, I knew something about earthquakes and I felt buildings were done to a certain standard. So I didn't feel I was at risk. There could have been a big earthquake and I could have been hurt. But I knew it was the previous year, so there's less likely to be another earthquake probably the year afterwards. So the perception definitely influences the outcome, plays a role in how you might, answer an essay. And you need to know the cultural determinants and the economic determinants, and they're on the next slide. So economic determinants at the left side here, social economic status. Am I wealthy? Am I middle class? Am I low income? That definitely affects my outcome because of the quality of the building I might be in, the crowdedness, the density of the area, and access to things. But these things are interlinked. And if I am wealthy or I'm middle income earning, then my education will be at a level, access to information will be at a level which might save my life. I might not live in a certain area. If I am poor, I might be forced to live in areas I shouldn't live in. I might be, if I look at the cultural aspects of the family situation, I can't leave because my family's there. I'm too poor to leave. I don't want to leave that area because everyone understands me that area. There's all these dynamics going on, and you have to be able to think about those things. And again, this, if I was you, so it's not superficial, I would pause the video here and just think, first of all, do I understand the term? Like, can I clarify social economic? Basically, my wealth thing. Access to money, that's availability to funds and things like that. What am I earning? That side of it. Can I write a sentence about what they are? But also, could I say, right, religion? How would that affect my perception of a hazard? Now, if you think on that one, you could go back to some areas where they attribute disasters to, supernatural events and how they appease that and how they cope with it and they use it to recover. So again, I would pause and have a go at doing that. Now, on this slide, this is just really a recombinant of what I've talked about. But again, it might be a way that you try to remember and learn things. Spider diagrams. And what I would do is I would do something like this and see if I can recall things and talk about these. So I'm not going to go through that again, but again, these are very visual reminders. So practice trying a spider diagram from memory. Other things that come into how we perceive things, if I just bring the whole oops, go back. Can I go back? It won't let me go back because of the video side of it. I'll talk it through because otherwise I have to start the video again. But the basic premise of that is if you have a high incidence of events time after time where there's a disaster, that's in your mindset all the time. And it colours your thinking, the safety that you take, the way you protect your family, the jobs that you do, the liability aspect. If a volcano hasn't erupted for 400 or 500 years or an earthquake hasn't happened for 100 years, it's out of your mind. Why should I pay that insurance? I'll be fine living here. That type sort of thing. So things like the magnitude, the incidents, the history, what's gone on in the past colours your thinking. And the longer you go without a threat, the harder it is to believe that it will happen to you. Now, the very last bit of this is here are some focus questions. So if you answered these based on the PowerPoint presentation that you've seen here, I'll do a PDF version of this so you can reread it. It's good to answer things like this. So can obviously, if you're doing this for the first time, you may remember from GCSEs and you could think of like, okay, I'll outline some primary impacts of an earthquake or storm. If this is a recap and you've already been taught this unit, you could obviously got everything at your fingertips. Definitely number two. I think number two is something that you're less likely to practice. So therefore, it's a potential weakness area. And then again, number three, I would say is easier to do if you've already studied the unit, but if you haven't, go back to what you've done at GCSE. Most of the GCSEs will have covered some sort of hazard management. Okay, so that brings us to the end of this lesson. And just to recap, it's what is a hazard? What's a disaster? Three broad categories of hazards: hydro, geophysical, and atmospheric. We've gone into hazard perception, the factors that influence hazard perception. And what I'll go into lesson two is I'll go through some of the key words like mitigation, fatalism, right? Adaptation, and there are other words there to do. And then I'm going to move into looking at two models which are really important: hazard management cycle and the parts model. They've been used quite heavily. Very important to get those right. Okay, they're not difficult, so I don't want to scare you. Okay, and there's some follow-up activities with this, and like always, for week one I'm doing 2 lessons, so there'll be something on those models I talked about, and I'll put some practice questions in which I said I'd mark. Anyway, thank you if you've managed to put up with me for this last half hour. That's the end of the lesson. Bye.